Hi to everyone. Today the topic is about Proba-3 mission developed by European Space Agency. Let's start with the introduction. So Proba stands for Project for Onboard Autonomy. It is the European Space Agency and the world's first precision format flying mission. Pair of satellites fly together to maintain a fixed configuration. It will demonstrate formation flying in the context of a large-scale science experiment. Two satellites together form an approximately 150-meter long solar coronagraph to study the sun's faint corona closer to the solar rim that has ever before been achieved. This will be a perfect instrument to measure the achievement of the precise positioning of the two spacecraft. So this is the spacecraft. Coming to the current context, Proba-3 mission will be launched on 4th December 2024 by ISRO on a PSLV C-59 rocket, that is XL version, to study the solar corona, that is the outermost and the hottest part of the sun's atmosphere. This mission will attempt the first ever precision format flying where two satellites fly together to maintain a fixed configuration in space. So Proba missions are a series of in-orbit demonstration (IOD) missions from European Space Agency for demonstrating and validating new technologies and concepts in orbit. It was developed under General Support Technology Program of European Space Agency. It is the latest solar mission in ESA's Proba suite of missions. The older Proba missions are Proba-1 launched by ISRO in 2001, Proba-2 launched by Rocket in 2009. Scientists from Spain, Belgium, Poland and Italy and Swiss have worked on Proba-3 mission. Next to the facts of Proba-3, date of launch 4th December 2024, launch vehicle PSLV C-59 XL version of ISRO, mass Coronograph spacecraft 340 kg, Occulter spacecraft 200 kg, high Earth orbit with an orbital period of 19.7 hours, apogee of 60,530 km and perigee of 600 km. Instrument is external coronagraph. The ground station will be at Redu, Belgium. Mission antenna will be at Santa Maria des Azores. Next, discuss about concept of mission. Proba-3 consists of two independent 3-axis stabilized spacecraft, that is Coronograph and the Occulter spacecraft. Both will fly close together on a highly elliptical orbit around the Earth with an apogee of 60,530 km altitude. The Occulter will precisely cast its shadow onto the coronagraph telescope, blocking the sun's direct light. This will allow the coronagraph to measure the faint solar corona in invisible ultraviolet and polarizing light for many hours of time. We can see the occulter disk giving shadow to the coronagraph spacecraft. Next, to discuss about the Proba-3 mission. It marks the next step in formation flying. It is the world's first of its two satellites, that is the Coronograph and the Occulter spacecraft. It will maintain formation to a few millimeters and arc-second precision at a distance of around 150 meters for 6 hours of time. In effect, the pair will be forming a virtual giant satellite, and this will be achieved autonomously without relying on guidance from the ground. Two small satellites will be launched into a high elliptical orbit in a stack configuration. This will be repetitively demonstrative, acquisition, rendezvous, proximity operations, formation flying, coronagraph observations, separation and convoy flying every orbit. It will be a laboratory in space to validate strategies, guidance, navigation and control, and other algorithms such as relative GPS navigation. So this is the Proba-3 orbit. So this is the Earth. This is the Occulter spacecraft. This will be the Coronograph spacecraft. So this is the orbit of the Earth. Next, so these two in between two spacecraft there will be a distance of 150 meters. This pair will do autonomously. To employ a suite of sensors, star trackers and satellite navigation are supplemented by inter-satellite radio links, optical camera tracing LEDs, a laser bounced back via retro reflectors, and finally shadow sensors surrounding the auspicious aperture. So go through the video. This is the occulter spacecraft. This is the occulter disk. This is the coronagraph spacecraft. So this is a solar panel. Laser is forming. So the distance between two spacecraft will be 150 meters. So this is the formation of flying of double satellites. That is flying double satellites, coronagraph and the occulter. So this is the coronagraph. This is the occulter. This is the occulter disk. In between the distance of 150 meters. So the coronagraph satellite hosts the coronagraph instrument pointing directly towards sun, equipped with comparable guidance, navigation and control system plus monopropellant thrusters. So the occulter satellite's main task is simply to block the sun for the coronagraph instrument using a 140 centimeter diameter disc. So this is the 140 centimeter diameter disc pointed away from sun. It steers using reaction wheels, gyroscopes, a star tracker, sun sensors and GPS receivers, while also hosting optical metrology sensors with cold gas thrusters for fine control of the formation. So coming to the scientific payloads, due to the corona's temperature, that is sun's outer temperature going up to 2 million degree Fahrenheit, it is difficult for any instrument to observe it closely. However, it is important for scientific study as well as space weather and its associated turbulences, that is solar storms, solar winds, etc. originate from the corona. This influences space weather and can potentially interfere with the smooth operations of all satellite-based communications, navigation and power grids on Earth. To study this, Proba-3 will have 3 instruments on board. The first one is Association of Spacecraft for Polarimetric and Imaging Investigation of the Corona of the Sun, or shortly referred to as coronagraph. Its field of view is between the Sun's outer and inner corona, that is a circular belt normally observable during solar eclipse event. So this will create artificial solar eclipse. An instrument has a 1.4 meter diameter occulting disc mounted on it, blocked the sunlight and facilitate a close-up view of this belt. The Proba-3 will embark other 2 scientific payloads. Davos Absolute Radiometer DARA. It's an absolute radiometer for measuring total solar irradiance. High Fidelity 3D Energetic Electron Spectrometer 3DWS. It's an embarked as a technology demonstrator. It has been developed as a science class instrument that will measure electron spectra in Earth's radiation belt. So this is the occulter spacecraft. This is the coronagraph spacecraft images. So you can see the disk of 1.4 meter occulter disk. This is the coronagraph spacecraft. Next, platforms of Proba-3. Both the larger coronagraph and the smaller occulter satellites are derived from European standard Proba platform. 340 kg coronagraph satellite has a volume of 1100 by 1800 by 1700 millimeter cube. It hosts the coronagraph instrument which will point directly towards the sun. The power is provided from a deployable solar array. Guidance, navigation and control GNC system consists of 4 reaction wheels, 2x3 axis gyroscopes, 1 3-headed star tracker, 6 sun sensors and 2 GPS receivers. Coronograph spacecraft also equipped with monopropellant thrusters, which will be able to perform large maneuvers such as formation acquisition at entry to the apogee arc and formation break at the end. 200 kg occulter satellite has a volume of 900 by 1400 by 900 millimeter cube. Main task is to block the sun for the coronagraph instrument with a 1400 millimeter diameter occulting disc on its face pointing away from the sun. Opposite side accommodates the satellite solar array. GNC system consists of 4 reaction wheels, 3 3-axis gyroscopes, 1 triple-headed star tracker, 6 sun sensors and 2 GPS receivers. The satellites also host the optical metrology sensor. So this is the occulter spacecraft. This is the coronagraph spacecraft. Coming to the Proba-3 technologies. First of all, inter-satellite RF links are maintained via S-band system between the 2 spacecraft. Around perigee, GNSS receivers acquire GPS signal and a dedicated relative navigation algorithm will provide relative position of the satellites. Satellites orbit carries them above the altitude of GPS constellation. That is, relative GPS is only used during lower segment of the orbit. For fine measurement during closer separation of less than 250 meters, relative GPS system is supplemented by a visual basal sensor. Set of cameras on the occulter spacecraft image and detect LEDs mounted on the Coronograph spacecraft. This system has been designed to robust to stray light such as reflection of sun on the larger solar array of the Earth or on the Earth. Next, coming to fine lateral and longitudinal sensor on occulter spacecraft shines a laser toward a corner cube retroreflector on the face of Coronograph spacecraft, which is reflected back in turn to the occulter. This provides relative positioning down to millimeter accuracy. Next, in continuation, final positioning technology is the shadow positioning sensor system based on photodetectors arranged around the lens of coronagraph to monitor the sun surrounding corona. If the approximately 8 cm diameter shadow is cast correctly centered onto the coronagraph, then it should be equal in illumination on all sides. Any discrepancy triggers a connection. Star trackers will be used for absolute altitude determination. These requirements demand the co-location of all star trackers and fine metrology sensors and instrument on an optical bench. Precision cold gas thrusters working at a 10 millinewton scale will be placed aboard the occulter spacecraft to precisely maintain the relative position of two satellites. Coronograph satellite will incorporate a 1 Newton scale monopropellant propulsion system for perigee passage maneuvers and collision avoidance maneuvers. Next to the views of sun and space weather. Coming to the sun, this is the high corona point, the low corona point, the gap between high and low corona, the aspect field of view. Coming to this point, aspects instrument will increase our close-up view of the sun and its corona from 3 solar radii down to 1.1 solar radii, permitting sustained study of the solar wind and coronal mass ejection. Next, to discuss about the project development. It is a project managed by the European Space Agency. The industrial development of the spacecraft on the ground segment is led by Senar Aerospace, which coordinates the work of a core team with the Airbus Defence and Space, Quintech Space, GMV, Celestial, Antwerp BV and Space Bell. Let us go through it. Proba-3 injection into orbit. This is the PSLV C-59 rocket carrying Proba-3 spacecraft. Final stage has been cut off. Proba-3 has been separated from the final stage. That's the end of our session. Thank you for your support. The source and credits are given to European Space Agency. Please like our video. For more educational videos, subscribe our YouTube channel, make a comeback. Thank you. Jai Hind.